Next up, we've got matrix multiplication. Two matrices can be multiplied together if the number of columns in the first matrix equals the number of rows in the second. So the rule for multiplying matrices is you can use the car key method of remembering it if you want to. And I've got that written on your page. Next, I'd like to show the order of each of these matrices. Essentially, the number of columns, that second number here, needs to match the first number, the number of rows in our second matrix if we're trying to multiply A times B, which is what we're trying to do here. So our method then goes something like this. First, identify the dimensions or the order of the product matrix. When we're multiplying matrices A and B, the product will have the number of rows of the first matrix and the number of columns of the second. And so AB will have 3 rows and 3 columns. Now, to find this entry in row 1, column 1, we're going to need to take row 1 of the first matrix and column 1 of the second, multiply the corresponding parts, and then add them together. So 3 times 4 is 12, plus negative 2 times 5, and that gives us 2. So row 1, column 1 will have an entry of 2. Next, I'm going to look in this spot, row 1, column 2. So we do row 1, column 2. 3 times 7 plus negative 2 times 1, which is 19. So we put that in row 1, column 2. Then for row 1, column 3, we go to row 1, column 3. 3 times negative 2, negative 2 times negative 1, giving us negative 4. Let me pause here just a second. Continuing on, to get our row 2, column 1, we do row 2 times column 1. 4 plus 0. Row 2, column 2, row 2, column 2. 7 plus 0. For row 2, column 3, row 2, column 3. Negative 2 plus 0. Last one, row 3, column 1. 8 plus negative 5. Row 3, column 2. 14, negative 2. Negative 4, positive 1. And so we've got our product, AB. Next up, our product, BA. So now we're doing B times A. When we're multiplying with matrices, remember, we need to make sure that the columns of the first matrix match up with the rows of the second matrix. So the second matrix, let me just rewrite this. So the columns of the first matrix need to match the rows of the second, and they do. And so we can multiply them together. And the product matrix will have 2 rows and 2 columns. So notice that the order when we multiply B times A is different than the order when we multiplied A times B. So now, first row, first column. First row, first column. 4 times 3 is 12. 7 times 1, negative 2 times 2. Add those together, and we get 19 minus 4, or 15. For row 1, column 2, row 1, column 2. Negative 8, 0, and 2. Add those together. Row 2, column 1, row 2, column 1, 15, 1, and negative 2. Add those together, and we get 14. Row 2, column 2, negative 10, 0, and 1. Add those all up, and we get negative 9. So as we've just shown, for these two matrices, AB doesn't equal BA. And so we can see that in general, the commutative property does not hold true for matrix multiplication. Something helpful to keep in mind. So that's what I have for lesson 1. See you in class.